Okay, everybody, welcome back. In this video, we are going to go over the POGIL for naming molecular compounds it's called Naming Covalent Compounds in section 6.4 of the Chemistry B Google Classroom, because molecular compounds are covalent. They contain covalent bonds, which means that they are very different from ionic compounds. Probably the most important way that they're different from ionic compounds is that they do not form ions and instead share electrons. Now, the formation of ions results in ionic compounds having chemical formulas that are the lowest whole number ratio of ions to ions in the compound. And that is not always true of covalent compounds. So we need to now have a new system of naming that accounts for the fact that you might have more than one compound made from the same two elements. And that is why we need a different system of naming when it comes to covalent compounds. So for example, I'm going to write down two covalent compounds, one of which you're very familiar, and the other which you have probably heard of, but you don't know it. Now, H2O, obviously, we commonly refer to it by its common name, which is water. But it does have a scientific name according to the rules for naming covalent compounds. The rules for naming covalent compounds say that in order to tell how many atoms are in the compound of each element, what we're going to use is a prefix that's going to designate how many atoms are in the compound. So in this compound, the two elements are hydrogen and oxygen, the compound being water. There are two atoms of hydrogen and one atom of oxygen. So therefore, this compound is called dihydrogen, because it has a prefix. The prefix di means two, so two hydrogens, and then monoxide, which means one oxygen. Literally, the name means two hydrogens and one oxygen. And that is the scientific name of water, dihydrogen monoxide. The second compound also has a common name, and its common name is hydrogen peroxide. And it's used often as a sanitizing agent, particularly in small wounds that aren't too deep, to get bacteria out and keep a wound from getting infected. Now, what's weird about this is you can see that hydrogen peroxide, or dihydrogen dioxide, its scientific name, has two atoms of hydrogen and two atoms of oxygen. And we don't reduce the subscripts the way that we did in ionic compounds. So it's dihydrogen dioxide, and we don't reduce the subscripts in the chemical formula. And the reason that we don't reduce the subscripts in the chemical formula is that when we were dealing with ionic compounds, the ions come together and they form a crystal. But when we're talking about covalent compounds, the particle that they come together and form is a molecule, which is also why this POGIL is named Naming Molecular Compounds. Molecules stand alone, okay? It's I think of it like an ionic compound is in the crystal is like a chocolate bar, and you can break it off in chunks, okay? But molecular compounds or covalent compounds form these molecules, and they're like Skittles, and they come one at a time, separate individual pieces, okay? So The actual chemical formula of the molecule for hydrogen peroxide has the chemical formula H2O2, or it has 2 hydrogens and 2 oxygens in the molecule, and they exist all by themselves. Now, how they are similar to ionic compounds is in this golden rule of compounds, and that is that the net charge is still 0. Okay, so ionic compounds don't carry a charge. They come together in a whole number of ratios to cancel each other out to form ionic crystals. Covalent compounds don't carry a charge. They come together in ways that they share or overlap their valences, and they actually physically join together like puzzle pieces to make a larger unit, which we call molecules. Neither of them are charged. Okay? Alrighty, so skipping ahead, they're going to ask you all these questions, and I really feel like you can probably answer all of the questions on the first page itself. But again, I like to hit in these videos the missing pieces, the ones that I have found that students come and ask me about after the fact. First and foremost, there is a list of prefixes because they don't always make, they're not always what we expect, okay? Like a lot of people expect bi to be two, but it's not, okay? So the numerical values and the prefixes that are associated with them are here in Model 2, and it really just goes down 1 through 10. So 1 is mono, or mono. 2 is di. 3 is tri, which we expect, like a triangle, okay? 4 is tetra, okay? We kind of think quad, but no, it's tetra, like Tetris. 5 is penta, like the pentagon. 6 is hexa, like a hexagon. 7 is hepta. 8 is octa. 9 is nona. And 10 is deca. And it's not the same as deca in the metric system. Okay, this one's spelled with a C, deca. Alrighty, so it's nice here because when you use these prefixes, the names really totally make sense. If we look at these chemical formulas over here, we can easily tell what the names are. You put the prefix in front of it, and you name the name of the element, and then if it's the last one listed, you drop the ending and add IDE. So this one right here is, well, we would expect it to be monoboron trichloride, but it's boron trichloride. Okay, so now we've just found our first exception. If mono is at the start, we don't include it. If it's on the first element listed, we don't include it. So this is boron trichloride. And look, see, I don't lie. All right. The second element then, following that same rule, would be sulfur hexafluoride. Then we have iodine heptafluoride and nitrogen triiodide. Now you try the next one in your head. It's N2O4. So that should be dinitrogen tetroxide. As you go through, you will figure out some instances when we don't say tetraoxide because it doesn't roll off the tongue easily. We say tetroxide. We kind of shorten it. And it becomes second nature after you practice it for a while. In this sense, it's easier to go the other direction because it's very, very clear. When you're reading the name, it's very, very clear how many atoms of each element that you're going to need, and you just find the name or the chemical symbol of the element on the periodic table and just fill it in. Okay. So when you get to questions 9 through 11 and you're done with them, you want to come to a consensus on how to modify the name for the molecules. You're going to say something about when and when not to use mono, okay? And when you drop the A on the prefix. Okay, those are two things that you need to pay attention to there in number 12. When do you not include mono? I'll actually write that. When is the mono prefix not used, and when do you drop the A on a prefix? Okay, and then for 15, it says collaborate with your group to write a list of rules for recognizing and naming binary molecular compounds. Okay, so the first element, you're going to name the first element. Can you see the part that says name? Yeah. With the prefix except when it's mono, right? And then the second element with the prefix plus drop the ending and add IDE. Okay. So for example, do this one because it's just a little bit different than the one we just did. This would be called dinitrogen pentoxide. All right. As opposed to this one, which would be called nitrogen dioxide. So here I dropped the A on the penta, you see? And here I left off the mono, according to those rules that you're going to write in number 12. All right, so that takes us up to page 3. Actually, I really feel like this bit here, 16, 17, and 18, based on what I just showed you, you should be able to write the names for those molecules as well as write the molecular formula from the name. And you're going to find out that writing the molecular formula from the name is, in a sense, quite a bit easier if you know the chemical symbols of the elements. You might have to look them up on the periodic table. Okay. Now, what about this bit here? The very last couple of pages I went ahead and included in here. And just so you know, this is putting together, combining what we learned from the names and formulas of ionic and what we have learned in the process of doing this POGIL about molecular or covalent compounds. Some of the compounds listed are ionic and some of them are covalent, okay? So what are the differences? Up here in the chart, we have some ionic compounds, magnesium fluoride being one of them. First of all, what's different, okay? Names and formulas of ionic compounds don't have prefixes. Not on the binary ionic compounds. Okay? And so over here, we do have prefixes. Okay. Ionic compounds have both a metal, which has a positive charge, and a nonmetal. Whereas our covalent compounds contain only nonmetals. All right, and the reason is the nonmetals aren't strong enough to pull the electrons off of each other. Okay, they're strong enough to pull them off the metals because the metals easily give them up. They have extras. So instead, they have to share. Okay, so in ionic compounds, electrons are gained, and those would be negative ions, or lost, those would be positive ions, which are metals. Okay, and over here, electrons are shared. They overlap their valence and they're shared, which kind of leads me to more differences. So I'm going to continue differences and put similarities down here. Okay, so how else are they different? Well, since electrons are shared, these exist as individual molecules, covalent compounds do, whereas ionic compounds form extended crystals. Okay. And so back to my analogy, ionic compounds are chocolate bars and covalent compounds are Skittles. So how are they similar then? Actually, there's not really a lot of ways in which they're similar. I guess I don't really have to draw a line because they're similar in that sense. We'll leave that in between. But from what we have seen, the similarities so far in all of the compounds above is that they all have two elements. Okay, not two atoms, but two elements, okay, which is called binary. They're called binary ionic or binary covalent compounds. And I think that's it. You should be able to then do 21 using your chart of similarities and differences. You're going to go through and you're going to take a look at those compounds. You're going to determine, are they ionic or covalent? All right. And then give the appropriate name according to the rules we learned. All right. Thanks, everybody. And I'll see you next week.